In this video, as part of Bayesian learning, let us study naive Bayes classifier. Although the boy, Although the Bayes optimal classifier obtains the best performance that can be achieved from the given training data, it can be very computationally costly. The expense is due to the fact that it computes the posterior probability for every hypothesis in H space and then combines the predictions of each hypothesis to classify each new instance. Basically, we need argmax. Vj is an element of capital V, P of Vj by capital D, where capital D is the data. We need so the map classification V map is equal to argmax. Vj is an element of capital V, P of Vj by A1, comma A2, and so on up to AN, where A1, comma A2, and so on up to AN is our data or the instance. Instead of using expressions of Bayes optimal classifier, we will use a different track which is significantly less computationally complex. Now, that the previous expression, that is P of Vj by capital D, can be written in terms of the Bayes theorem. So, invoking the Bayes theorem, we shall write V map is equal to argmax. Vj is an element of capital V, P of A1, comma A2, and so on up to AN given Vj into P of Vj divided by P of D, that is P of A1, comma A2, and so on AN. Now, for every Vj, this is going to be present. So we can replace this by 1. So V map is equal to argmax. Vj is an element of capital V, P of A1, comma A2, and so on up to AN given Vj into P of Vj. It may be noted that the expression need not be calculated for all hypotheses, unlike the Bayes optimal classifier. Because of this reason, complexity is drastically reduced. Now, the question is how to calculate the factors of the present expression. We can use the relative frequency concept of probability calculation. P of Vj can be calculated by using relative frequency concept in a straightaway concept. However, P of d by Vj calculation, even with the relative frequency concept, will be cumbersome. The calculation of the expression is still complex. So we will have a reasonable assumption, which may be true in some cases. Having a reasonable assumption that individual attributes given target are statistically independent will simplify the calculation. This statistically independent, it may be true in good number of cases, but if they are not true, and we will have to look for other option. VNB is equal to, that is classification based on naive Bayes classifier is equal to argmax. Vj is an element of capital V, a product of P of A by Vj for all i's. Now let us do an example problem. There are 14 instances given. The target is whether a person will play tennis or not. The attributes are outlook, temperature, humidity, and wind. So 14 instances are there. Outlook can take up sunny, overcast, and rainy. Temperature can take up high, moderate, and cool. Humidity can take high and normal. Now the wind can be weak or strong, and the person may play or may not play. That is the classification. The target values are yes and no. Now, the problem is we will give one by one instance and we need a proper classification for that. So let us consider an instance. Outlook is equal to sunny, temperature is equal to cool, humidity is equal to high, and wind is equal to strong. Our task is to predict the target value, yes or no, of the target concept play tennis for this new instance. So the expression to be applied is this. Naive base classification is equal to argmax. Vj is an element of capital V. P of Vj into product of P of Ai by Vj for all i's. Now, argmax, which is equal to argmax Vj, is an element of capital V. P of Vj into P of outlook is equal to sunny given Vj into P of temperature is equal to cool given Vj into P of humidity is equal to high given Vj into P of wind is equal to strong given Vj. Now, as per the expression, we need to calculate P of Vj by capital D for the set of classifications. P of Vj by capital D is equal to P of Vj into product of P of Ai by Vj for all I. We need to calculate this particular expression for the set of capital V. So in our case, the set capital V has two classifications or two target values. One is yes and the other one is no. So we have to calculate P of S by P of S given D and P of no given D. P of S given D is equal to P of S into P of sunny given S into P of cool given S into P of high given S into P of strong given S. And similarly, P of no by capital D is equal to P of no into P of sunny given no, P of cool given no, P of high given no, P of strong given no. Now we can go to the table and count the required numbers and write the probability because as I already told you, we are calculating the probability based on relative frequency concept. P of S is equal to 9 by 14, which has been inferred from the table. Total number of examples are 14 and 9 S's are there, so 9 by 14. We have 5 no's, so P of no is equal to 5 by 14. Now given yes, we have to count the number of sunnies and that will be 2. So P of sunny given yes is equal to 2 by 9. And given yes, the number of cools we have to count, that will happen to be 3. And P of cool given s is equal to 3 by 9. Similarly, P of high given s is equal to 3 by 9. P of strong given s is equal to 3 by 9. And similarly, we can write P of sunny given no is equal to 3 by 5. P of cool given no is equal to 1 by 5. And we can write P of high given no and P of strong given no. Now, on substituting these values in the two expressions, P of S given D and P of no given D, we get P of S given D is equal to 0.0053 and P of no given D is equal to 0.0206. So based on our algorithm, VNB is equal to argmax Vj, an element of capital V P of Vj by capital D, we find the higher value is or the maximum value is 0.0206. So the corresponding target value is no. So the answer is no. We can conclude the person may not play. We will say the person will not play tennis. I hope this video was clear to you. This topic was clear to you. If you like it, please give a like for this. Thank you.